Welcome to Hyperphysics. In this video, I'm going to talk about an easy trick that you can use in your physics MCQ examination. That is a series expansion method. So let's get started. So here's a question that we can solve here using this method. A body of mass m falls from rest at a high edge under gravity through a dense medium which provides a resistive force F equal to BV, where B is a constant and V is the speed. We have to find the magnitude of kinetic energy. So we can diagrammatically see the scenario here. You have a body of mass m that is falling through a dense medium, which is having a resistive force F is equal to BV. So what we do is we have to find the kinetic energy. So assume the case, okay. So you have to assume what happens if there is no resistive force. The resistive force I'm denoting is it as resistive force Fr to be equal to 0. That is BV equal to 0, right? So what happens where in this case if a body of mass m that is having at rest at height h, and what happens if this scenario where the resistive force is 0? In that case, by energy conservation, you have energy mgh, that is height at h, that is a potential energy that is converted to kinetic energy, right? Completely that is converted to kinetic energy. So in that case the kinetic energy will be equal to the potential energy, where Fr equal to 0, that is BV equal to 0. So here we can see in the options we have an exponential of minus term, 1 plus exponential of minus something, and we have a tan hyperbolic function here, and 1 minus exponential of minus something. Okay, so what we do is we expand these options here. We know that exponential of minus x is by Taylor series, we know that it's 1 minus x plus x squared by 2 factorial minus x cubed by 3 factorial, like that, right? And so on. So what we do is we expand this equation and see at a very low approximation we're getting the kinetic energy to be equal to the potential energy. So what we do is we just check the first option here. So I'm going to check this first option here. I'm going to write it here. Okay, so we have m square g over 2k exponential of minus 2k h by m, right? So we have 1 minus 2k h by m. So we just expand this thing, right? So we have m square g over 2k minus m square g times this quantity will give you mgh. So this is the kinetic energy in the case of option A, right? So we know that, but here there is an extra term here, so we'll check other options also. Okay, so I'm going to the answer itself. Other options you can check itself. So the answer I'm going to do is option D actually. So we have m square g by 2k times 1 minus, you have exponential of this term, right? That is 1 minus 2k h by m, right? So here if you expand this thing, you will get m square g over 2k times 1 minus 1 plus 2k h over m. That is the kinetic energy. So you expand this thing, you will get m square g over 2k times 2k h by m. That will lead to mgh. So the kinetic energy will be equal to the potential energy mgh if you consider this exponential term to be very small. So in that case, other options won't give you this value. As we can see in the option A, you have an extra term of m square g by 2k, something like that. You have a tan hyperbolic function, also have a proper expansion also. So if you check this option, you will get the option to be option D. So the kinetic energy is equal to potential energy for Fr equal to 0 or Bv equal to 0. So by using this Taylor expansion of exponential of minus x, you can easily find this kinetic energy for this question very easily. So let's go to the next question. The question goes like this. If a ball is dropped from rest at a height h, and if the drag force from the air takes the form Fd equal to minus Bv, then it can be shown that the ball's height as a function of time equals. So what you have to find is y of t, right? The displacement as a function of time. So let's consider the case where Fd equal to 0, like we always do in this method. So what happens when Fd equal to 0? You know, the ball is dropped from a height h, and we have the displacement y of t. If Fd equal to 0, let's say if Fd equal to 0, you have the total displacement to be half h minus half gt squared, right? So in the case where y of t is where Fd not equal to 0, in this case the distance it travels will be less than y of t, that is traveled for Fd equal to 0, right? This is the concept that we are going to use here. So in this case, what I'm going to do is I'm going to see in which option gives me this value h minus half gt square for y of t where Fd is equal to 0. So in that case, I'm going to expand this equation. So I'm not taking all the options and solving it. So rather than I'm going to use the correct option here, and just wanted to show how this thing is going to work. So what I'm going to do is I'm going to take y of t to be, let's say y of t to be equal to h minus mg by b times t minus n m by b times 1 minus exponential of minus bt by n. That is option C that I'm going to use. Okay, so what we have here is I'm going to expand this thing as 1 h minus mg by b times t minus m by b times 1 minus exponential, not exponential, it's bt by m plus half bt by m the whole square. This bt by m the whole square times 1 by 2, that you can actually get the idea from here itself, because if you want something like a square term of time, you need to add this term also, right? This bt by this t square term has to be also, that is this exponential of minus x will be 1 plus 1 minus x plus x square by 2 factorial, right? So you have to include this term also to get this kind of equation here. So I'm going to rewrite this equation as y of t equal to h minus mg by b times t minus m by b times 1 minus 1 minus bt by m, that is actually it's plus, minus half b square t square by m, right? So what I'm going to do is I'm going to expand this thing. This is y of t, that is equal to h minus mg by b times t minus, this is 0 and this will cancel out, m and m will cancel, and we have t minus t plus half b square t square by m times, you have a m by b, right, from this one. So you have h minus mg by b times, this will be 0, that is half b t square, right? M and m cancels out, you have a b, you cancel with this one, you have m by b t square, that will be equal to h minus mg by b times half b t square, right? Oh, but here actually this m square, right? Because you have a m bt by m the whole square. So you have a m here, this m square. So you have one more m here. So this will cancel out here, and this b will cancel out here, which will give you h minus half g t square. So you get y of t to be equal to h minus half gt square for option C. So in this case, if you're going to expand the other options also, you won't get this h minus half gt square for this approximation. So if you do this thing, you can just check it out on yourself. So in this option, in this case, the option is option C. If you are following this exponential, expanding the exponential using Taylor series, then these questions will take around 2 minutes to solve. That's all. Otherwise, it will take around 5 to 10 minutes to solve this simple problem. So better be careful using this method. I'll solve one more question regarding this series method in the next problem. So next we have a question here. The question goes like this. Consider a particle of mass m suspended between two identical springs of same spring constant k. The system was found to be a nonlinear system with f proportional to x cube, where x represents the displacement. Find the value of force that is acting on the system. So the diagrammatic explanation is like this. So you have two springs and a mass in between, and you apply a force in the horizontal direction. The spring goes like this, so it will have an oscillation. So this oscillation, this force F is proportional to x cube. The force that means here is the restoring force that we have to find. This is the F, capital F, that we have to find. So what it tells is that we have to check which option gives actually something like this, minus kx cube, right? Because we have to find, because minus kx cube, in the sense the force, restoring force is in the direction opposite to the applied force, right? So we have to find the force that is acting on the system. So what we do is we do the same expansion technique that we are going to do. So in this case, what I'm going to do is I'm going to use this option, option C. Other options also you can check, but for the sake of saving time, I'm going to use the option C here. So we have force equal to minus 2kx. The option is like this, times 1 minus 1 over square root of 1 plus x by a the whole square, right? So what I'm going to do is I'm going to take this up. So I have minus 2kx times 1 minus 1 plus x by a the whole square times minus 1 over 2. That's right. So that's the equation we are going to get. So what we do is we expand this thing, that is 1 plus 1 plus x whole to the power n. You have 1 plus, nearly it's 1 plus nx, right? So you have n here to be equal to minus 1 by 2 in this case. So what I'm going to write is f equal to minus 2kx times 1 minus 1 minus 1 by 2 x by a the whole square, right? In the near approximation of 1 plus x whole to the power n. So the restoring force can be written as f equal to minus 2kx times 1 minus 1 plus 1 by 2 x by a the whole square, right? So I'm going to rewrite this as f equal to minus 2kx, and this will be 0. This is 1 by 2 times x square by a square. So you will get the answer to be f equal to minus k x cube by a squared. So this is force is proportional to x cube, right? That is that is there in the question itself. It is shown that the system was non-linear and the force is proportional to x cube. And if you try to open this thing, they expand the whole other option a, b, and d also, you won't get the f proportional to x cube. You will have something like this, something like this. You have a f equal to minus 2kx times x plus some x cube term, some kx cube term is there. Okay, so this won't be equal proportional to x cube, right? Because we have a x dependence also, we have x square dependence also, and x cube dependence also. So only the option C will give you the correct value of this scenario where f is proportional to x cube itself. So otherwise, if you are trying to do this problem, if you make any mistake while choosing the displacement which is happening during the applying a force here, it will actually give you a wrong answer if you make any mistake in that part itself. So if you're doing it in the long way, it will be very difficult to do this question, and you have to be very lucky to get the correct answer. So if you are using this method, this series expansion method, it will take at least like 2 minutes or 3 minutes to solve this problem, right? So I guess you guys like this video, so please like, share, and subscribe to my channel. And also please share it with your friends who are finding it difficult to solve physics problems. I guess I'll be helping one of them for sure. I'm very confident that I could help one of them who is finding difficulty in solving problems in physics. So please subscribe and please like my video. So thank you for watching. Thank you.